A 6-meter-long massless spring rests on a smooth and level table. The 6-kilogram mass is moved 2 meters to the right from its equilibrium position and is released at t = 0 seconds. The system is seen to oscillate with an angular frequency of 8 radians per second. What is the instantaneous horizontal acceleration of the mass at t = 0.3 seconds? Okay, so recalling our crash course video, the acceleration is going to be equal to the second derivative of the displacement equation. So the displacement equation is a cosine omega t. Okay, A stands for amplitude, omega stands for angular frequency, and t is for time. Okay, second derivative of that will give you acceleration, which means let's find the first derivative in terms of t. First derivative will give you velocity. So you get negative a omega sine omega t. So this is the first derivative of this in terms of t. Now, second derivative of this in terms of t, which will be derivative of this in terms of t, you get negative a omega squared cosine omega t. Okay, so let's write it over here. A omega squared cosine omega t. Now let me repeat. A is for amplitude. Amplitude means the distance from the equilibrium. So in this case, amplitude would be 2. Omega is the angular frequency, so which means angular frequency is 8 radians in this problem. Cosine omega again, which is 8 multiplied by the time. So it's asking what is the instantaneous horizontal acceleration of the mass at t = 0.3. So this is the time, okay? So 0.3 is the time. And now you want to solve for acceleration. So you can use a calculator. So let me plug in the values. You have a negative 2, 8 squared cosine 8 times 0.3. You get a positive 94.38, and then it trails off. So acceleration is going to be equal 94. Well, we need to write the sign for this because there's two directions, okay? So a positive 94 let's round it, 94.4 meters per second squared. All right, now here's the thing. Whenever you do this, whenever you work with omega, make sure that you set your calculator to radian, okay? Not degrees, because if you do it in degrees, you'll be wrong. So make sure that your calculator is set in radians. And then this is the answer.